Welcome to all. I am Part-1 going to present about steam nozzle, the types of steam nozzle, definition and the advantages of these steam nozzle going to discuss in this presentation. First of all, we need to know what is the meaning of steam nozzle. A steam nozzle is defined as a passage of varying cross section through which heat energy of steam is converted to kinetic energy. Its major function is to produce steam jet with high velocity to drive steam turbines. There are different types of nozzle. According our availability and requirement, we can use those nozzles. First one is convergent nozzle. This is a common type of nozzle. The cross-sectional area decreases continuously from its entrance to exit. It is used in a case where the back pressure is equal to or greater than the critical pressure ratio, which means when the air or steam enter into the pipeline, if there will be a area obstruction or area reduction will be coming gradually, that will leads to make high velocity where pressure also going to drop. In order to the convergent nozzle is constructed to require applications. In the figure clearly shown that entrance of the steam will be higher area and then exit of the steam will become very small area compared with the entrance of the nozzle. The divergent nozzle is used to create high pressure from the high velocity. At entrance, the velocity will be higher. After exit the steam, the velocity automatically drop down. The pressure will be increased. The cross-sectional area of divergent nozzle increases continuously from its entrance to exit. It is used in a case where the back pressure is less than the critical pressure ratio. This is divergent nozzle, and then convergent and divergent nozzle, where if you see, this is the combination of convergent nozzle and divergent nozzle. The right hand side, the convergent nozzle exit is connected with the divergent nozzle entrance. Accordingly, prepared this convergent divergent nozzle, the cross sectional area first decrease from its entrance to throat and then increases from throat to exit. Here the figure is shown clearly about the convergent divergent nozzle. Initially, the entrance of the convergent nozzle will supply with high pressure low velocity gases through to the throat area. In between, the steam flow will be a subsonic flow. After entering into the throat, the steam flow will be a supersonic flow, where the high pressure will be converted into low pressure and low velocity gases is converted into high velocity. This is the divergent section. After supersonic, we can be able to create high thrust or pulling power at the exit of the nozzle. Then degree of undercooling and degree of supersaturation. The degree of undercooling is then the difference between the saturation temperature and the supercooled temperature. The ratio of supersaturation pressure corresponding to the temperature between supersaturated region is known as the degree of supersaturation. This is the way the convergent divergent nozzle is working. And there are different shapes of nozzles and diffusers are there. Here the pressure and temperature decreases and MC increases. Mach number is less than 1 number means the nozzle entrance will be high compared with the nozzle exit area. The Mach value is greater than 1 means the entrance of the nozzle will be smaller area compared with the exit of the nozzle section. Then the pressure temperature increases, the MC is also decreases. Where the diffuser is vital role, the diffuser will have the small entrance and big exit where we can get the supersonic flow. If you see the Mach number value will be greater than 1, the diffuser entrance area is higher than the exit area where we can obtain or we can achieve a supersonic flow. Then critical pressure ratio. The critical pressure ratio is the pressure ratio which will accelerate the flow to a velocity equal to the local velocity of sound in the fluid. Maximum gas flow through a nozzle is determined by the critical pressure, the pressure which the area is minimum, and discharge per unit area is maximum is called critical pressure ratio. Then the list the factors which influence nozzle efficiency. When the steam flow through a nozzle, the final velocity of steam for given pressure drop is reduced due to the following reasons. The friction between the nozzle surface and steam, the internal friction of steam itself. Third one, the shock losses. These three factors is well known as well as more influence nozzle efficiency. And effects of friction in nozzle. In generally, the friction loss considered as a major losses. So that the effect of friction in nozzle is a important part to affect the efficiency of the total system. In practice, there is friction produced between the steam and the sides of the nozzle. This friction causes a resistance to the flow which is converted into heat. The heat formed dents drying the steam. The expansion is no more isentropic and the enthalpy drop is reduced. The final dryness fraction steam is increased as the kinetic energy gets converted into heat due to friction and is absorbed by steam. The specific volume of steam is increased as the steam becomes more dry due to this friction reheating, which means the volume of steam is increased as well as the mass flow rate also increased. As the steam becomes more dry, dryness fraction of the steam will be increased, which will leads to the friction reheating. So these kind of factors very important while discussing about the nozzle efficiency. And then definition of nozzle efficiency is therefore defined as the ratio of the actual enthalpy drop to the isentropic enthalpy drop between the same pressure. We also calculate the nozzle efficiency by actual enthalpy drop divided by isentropic enthalpy drop. Also, the coefficient of velocity in nozzle, the ratio of the actual velocity of gas emerging from a nozzle to the velocity calculated under ideal conditions. It is less than 1 because of friction losses and carry over losses. The velocity of steam at the exit is sufficiently high, thereby the resulting in a kinetic energy loss called carry over loss or leading velocity loss. Then supersaturated flow. When steam flows through a nozzle, it would normally be expected that the discharge of steam through the nozzle would be slightly less than the theoretical value, but it has been observed during experiments on flow of wet steam that the discharge is slightly greater than that calculated by the formula. The converging part of the nozzle is so short and the steam velocity is so high that the molecules of steam have insufficient time to collect and form droplets so that normal condensation doesn't take place. Such rapid expansion is said to be metastable and produces a supersaturated state. Effect of supersaturation. There is an increase in the entropy and the specific volume of steam. The heat drop is reduced below that for thermal equilibrium. As an consequence, the exit velocity is reduced. The dryness fraction of steam is improved. Thanks for watching this video. I am going to continue this part in the upcoming next part.